All right, so this is going to be a walkthrough of a Idle Heroes like battle system demo that I put together. Someone was asking about if there were any tutorials for an Idle Heroes like out there, and we couldn't find any. So of course I got sucked in and put the project together. We can just run it here really quick, and what I'm going to do is I'm just going to kind of talk about the design at a high level, some good, bad, and ugly on the project. This is my first attempt at a battle system for an Idle Heroes like. So I'm not saying it's the gold standard by any means, but I feel pretty good about it. There are definitely some things I'd like to improve and add and all of that, but the goal was just to get a battle system sort of mechanic put together. So with that, I'll just dive right in. We have three different modes. You have team battle, which I can talk about that while we look at it, which is all the units from one team. I don't think I have the output going. We've got some sounds in there. There we go. So we got one team, the player team on the left, the enemy team on the right. Player teams are gonna, all the units on the player team are gonna go, and when they're done, the enemy team's turn. And so that's one mode. We do have 4 units. I don't think they're all seen here. We have the warrior, the archer, the cleric, and the wizard, which isn't seen. Each one has 2 to 3 different abilities. You have like your basic melee attack or ranged attack. Then you have your a second tier ability of some kind, whether that's heal, the shield, the invulnerability shield, or shield bash. And then we also have some ultimates, and that's what the yellow bar is the ultimate bar. But it's a hybrid bar because I was playing around with different ways to spend what I refer to as ability juice or mana. And what I wanted to see ults as part of the testing, so I wanted to make sure that the ult bar was always growing. So I didn't like the fact that we were spending some of that ult bar to cast other abilities, and so I made all of the other abilities like a 0 cost. So you cast them, doesn't take any of your ult away, and then you finally build up to your ult and you use it, like we just saw the cleric use his ult there. Okay, so all right, so this is the team-based battle system, and then, oops, didn't mean to go all the way out. Then we have the unit speed battle, and in this mode, it's the fastest unit goes first, regardless of teams. So you might see 3 in a row on one team, and then it bounces around. All of these things get more and more interesting as you get fewer and fewer units on the screen, because what happens is if one team has only 1 unit and the other team has, say, 4, well, then I think in this mode it's the fairest, because all the units are just going to go in order regardless. But if you go to like team battle, they're going to keep jumping all the way out. Sorry. In team battle, it would be 1 versus 4. That same unit's always going to go on their turn, and that's okay too. But I guess the team speed battle, this mode is where it gets a little wonky at the end. And this one is both teams take a turn back and forth, and it's the fastest unit on each team that goes. And so in this mode, if you have 1 unit on one team, 4 on the other, that 1 unit gets to go every single turn, while the other 4 are taking turns, right? So anyway, some different modes to play around with. That's what this is. It's sort of like a POC. We're testing things out, seeing how they work, because we're not necessarily making an Idle Heroes exact game. We'll be tweaking it in some way and playing around with some different stuff. Okay, so that's all there, and here's what I've been meaning to do, is just hit cancel battle, and that'll take us out. We have the 3 different modes. You can run automation, so I can run like start team speed automation, and that's just going to, when all the units on one team die, we end up at either a defeat screen or a victory screen, and with automation it just loops and we start over. And so since this POC is just it's like just a demo, it's just the battle system, I don't have the concept of the players sort of owning units, or and there's no unit manager or anything, and we can get into the code here in a second. And that means that we just generate the units on the fly every single time the battle starts. So it's randomly generated. So let's dive into the code. Edit here. And there are a few interesting things that I wanted to talk about here. I wanted to talk about the signals, my use of signals, because I am using, and I think this will be interesting to people who are new to Godot. I'm using global signals, I'm using local signals, I'm also awaiting for global signals through coroutines, and I'm also awaiting for local signals in a remote class. So a remote class is awaiting for a local scene's signal to fire, which I think is really neat and powerful, right? And then we could take a look at the structure that I have in my project, because that'll be interesting to people that are new to Godot, because a lot of people are always asking how should I organize my project, and I think I've got a fairly standard way of organizing. And then we'll talk about the unit inheritance that I set up briefly, and then we'll talk about the way abilities work and the challenges sort of involved with that turn-based system where you're trying to manage all the different animations. You can imagine like a unit, if it has a melee attack that goes across the screen and then comes back, you have, first off, you have the dash across the screen that you're waiting for. When it's done, then you need to trigger its weapon animation, and when it's done, you need to trigger the enemy's damage animations, and then you need to determine if that enemy is going to die or not, and then you need to reset this unit's dash back to their start, and then you need to continue to the next unit. And so how are we managing all that? I'm going to talk about it at least at a high, quick level, kind of show where things are happening without getting too deep into the weeds. That's my goal. Okay, and I think that's about it. So let's just start with let's start with the unit. So we have our base unit here, and what this is, it's all the standard components of all of our units. So anything that's common among all of them, they're all humanoid units right now, but I think that even if I were to add, like, say, an octopus, which I like thinking about in terms of an example, is that it has 8 legs and they're all going to animate in different ways, and which is different from our humanoid units. But in here, there's nothing to do with the unit's legs or arms or body parts. It's all very generic. And so we have a base container, and it has the floating text container. So when we do damage, we see the floating text. It has unit bars, a speed label if you want to see that, and that's for when I'm doing testing and I want to see which unit's going first. And then an ability container, and that's where we dump all the abilities. And then our unit selection container rect, which I didn't show, so I'll debug that here and I'll just show that. I've got a little debugging utility. When you click on a unit, it's going to open this UI and it's going to have a bug. Why does it have a bug? Let's see. This is null. Okay, I'll have to look at that. What I was supposed to be hiding there is the text on the dialog right here, but I'll fix that. So so for debugging purposes, I want to change this wizard because I want to do a bunch of testing with archers. This allows me to just change a unit, and it also restores the full health. Not necessarily restore, but it's a new unit, so it has all new health. So if I want to refresh a unit, I can do that. So that is this unit selection color rect. It's just a little tiny dialogue. And this is where I click to actually open that dialog. And so the base container is separate from the sprite container, because the base container contains a bunch of things that I don't want to reverse. You have to keep in mind that all of these units are the same, they're just reversed. I'm flipping the scale, the scale.x, and we need everything to work correctly. So we need the health bars still going from left to right, or right to left, or whatever you want to say, but we don't want those things getting reversed. But in the sprite container, we actually do want stuff getting flipped, and that's like effects and other things we want to see flipped, and body parts as well. So I'm going to stop that so I don't have to listen to it. And so let's see. So I have the total sprite container, which is what we flip, and then I got the shadow sprite, which doesn't matter when it gets flipped. We have the opponent mark, which this is where the opposing unit is going to come attack me. That's where I want it to go. So if you have different units of different sizes, then you can move this around based on that individual unit. And then we have the tilt container. This is for the death animation. I think if I were to actually invest in this game going forward, I would actually have the unit probably rigged out so that I can have much more sexy animations, if you will. You know, body parts moving all over the place or collapsing or being knocked back, all that kind of stuff. Because right now, just this, when they die, they just fall over backwards. It's a bit silly, but whatever. I got something in there to show. And then we have our effects container and temp container. The effects container is for long-term effects, such as the vines. I think they're called Entangle, and those stick around for a few rounds. And it's up to the battle manager to check the effects every round, increment them, and then dispose of them when they have expired. With the temp container, though, I put temporary effects in this one, and those effects tend to clean themselves up. So, like a fire effect or a healing effect, those things show up, and then 2 seconds later they're gone, and they just clean themselves up. And I wanted them separate because I iterate through the effects container for any effects on each unit every round, and I don't want to have to filter out other types of effects that might be sitting in there. So this is the base unit. All other units inherit from this, and the way you do that is you right click on base unit and you choose new inherited scene, and I'll do that here. And what we see is it ends up creating a new tab, unsaved, and all of these nodes here are yellow because they're all inheriting from the base scene, and that just lets you know, hey, this is an inherited scene. You generally don't want to be messing with it here, because if you want to make a change, you want to do it on the base scene and for all units, but you can. Now, let's see. So there is some wonkiness with this inheritance. Like if I go into the base unit and start renaming things or moving things around, it just wreaks havoc on any other unit that inherits. So it's really finicky, and you really have to, you do really have to fight with it to get it where you want it, and then don't mess with it kind of a situation. Otherwise, you know, things can blow up on you. So you have to be careful here, but it's worth it once you get it working just right. And I managed to get it working just right in this solution. And so let's look at the archer here. So it has a couple special nodes in it that are just for the archer. It's got its body parts, which is the back arm. If I click on the back arm, so there's my back arm, so I can swivel it based on its pivot point right there. And then I have the body sprite, which has a child front arm on it, so if I move that around, and then it's also got an animation player, but that's it. So basically the archer is like 3 additional nodes with some sprites, and then the animation player, because each unit has its own set of animations because they have different arms, different attacks, whatever. And cloning animation player is problematic anyway, so you have to basically create a new animation player for each unit anyway. But so that's all I would need. So for this new unit, if it was a humanoid unit and it was going to be similar to like an archer, having back and front arms, I could just copy these 3, bring them over into this unit, put them in my tilt container, and then add an animation player, just to give you an idea of what setting up a unit would be like. And we would call this the something ninja. So now I have a ninja unit, and let's see, new folder. I don't think ninja. All right, so now I can save this unit in my scenes folder. Where'd you go? Scenes units. We should talk about that really quick. The folder structure. So there's the ninja, and then the other thing you have to do anytime you're cloning an existing scene is make sure that you check the script and do what you want with it, because it always references the old scene. So in this case, I want to get rid of it, add my own script for the ninja.gd, but I actually want to copy everything that's in here because we're going to reuse a lot of it. And so here is the archer's script. So we're going to change this. We would change all the attributes as appropriate, and then we're gonna have to go create some new ability scenes, and get all that working, and then append those new abilities for the ninja, and then we have to probably create some animations for the ninja based on whatever abilities we have and stuff. So get rid of any archer specific stuff, keep the rest. We need to hook up our animation player event, because I know that we're going to end up using it, which is anytime the ninja completes an animation, we inform anybody who's listening, and the person listening is actually the abilities, which we'll get to here in a second. Abilities are listening for, hey, when is my unit done doing a thing, so I can continue to the next step of that animation sequence. And so this is a use of global signals. But we'll dive into signals here in just a second. Let's talk about the scene tree for a quick second. So this is pretty typical, I think, based on my experience and all the different projects I've looked at. I've got an assets folder. I put all my sprites and things in here. I tend to organize them pretty close to what I have in my scene tree based on the name of whatever the thing is. I do put my sounds in here, particle effects, backgrounds, themes would go in here as well. And then I have my scenes, and I try to keep this as flat as I possibly can because it's just easier to find something, because this is alphabetical order. I can quickly scroll through it. Even if it's long, I can quickly scroll through it and find things. As soon as I start nesting things like this, then I forget that it's nested, and I forget what a thing is nested under. Like, I'm looking for my battle manager, scrolling up and down. Is it I forget. Is it a singleton? Is it something else? Is it a window? I don't know. And I go digging for stuff. And some of my other projects where I did a lot more nesting, I just kept finding myself searching and not finding stuff right away. While anytime it's in the flat list, I find it almost immediately. So whatever you want to do there. I probably talked too long about it. Anyway, so if you look in each one of these, abilities is one that's good for nesting. Obviously, you have a bunch of abilities that are all inheriting from a base class, and then, but most of these other ones, if we look at like default screen, it's got the scene and it's got its script. And so if we look at scripts, these are just some very common helper functions that are static, so anybody can call them at any time. And then we have singletons, which are global signals and global classes. So we got an audio singleton here. So this is all hooked up and ready to go to play different sounds on different channels. Got a master channel, effects channel, voice channel, music volume. In this project, I think everything is on the master. If I look down here at audio, I do have 2 channels, so probably routing all the sounds through effects. And then normally I would have a settings screen where you can adjust all your volume settings, but I don't think I included that here in this project. So this is basically something that would help you get started building that out. And then in the game, this is game specific global classes. And we've got debug, so just for a few debug switches, global enums, and here's our signals. This is a big one. And then test automation class and our unit factory. And I did the unit factory this way because I don't, like I said, I don't have anything that's managing units or storing units like a player in this demo. So needed some place to be able to create new units and sort of store all of that new unit logic. And this was it. And the other thing was I needed, when changing a unit while in a battle, I needed an easy way to call into the unit factory of some kind to create new units on the fly. So that's why we ended up with this unit factory here. So let's look at signals next. So signals. So this is how you define a global signal, which is in a global class. And the way you define these globals here so that they're accessible from any class in your project is you go up to project settings, you go to auto load, and then you just find that whatever script it is. So all mine are in singletons. Go here, you select it like that, I'm not going to hit open because we have it right here. Once you have the path defined right here to your script, then you just give it a good name. I like to keep my names nice and short because I reuse them all the time generally. And so I would call it signals right here. And then we save that, and now it's a global class. It's going to load at start and be accessible to all other classes in your project. So if we look at just about any place, let's go, signals is what I named it. So we're going to go into an ability here. This is the Aura of Invincibility ability. And we can see that I've got this global signal, so I can access all my global signals using the name. We can emit one of them, ability completed. So if I look at my signals list, ability completed is here. And then I can pass in whatever amount of variables I want. And one of the things I always do is name my signals the same. So if I search for my signal name, I'm going to find the function here in the list. Okay, but more importantly, it helps with searches is that I'm using the same name for the signal as for the function that I end up calling. And so I found that early on, I used to have two different names, ability completed and on ability completed, something like that. But if I did this, then what would happen is I would have to search for my signal, find the connection here, then go, okay, well, here's my method. Now I can go to this one. But instead, if they're all the same most of the time, then when I do a search, no matter where I'm at, from what signal, and I look through the results, I can find the function because it's the same name instead of having to go to this connection here first. So I found that helpful. Now you can't always do that. I think with local signals, you have to change it a little bit, and I'll talk about that here in a second. But so this global signal can be called from anywhere, and I'm calling ability completed and passing an active unit, and the battle manager is listening for that global signal right here as we defined because we made a connection to it, the global signal. And then if I go, now I lost it, if I go back down to it, so this is, it's going to get called and it's going to get that variable passed in right here, active unit, and then we can do whatever we want with it. And so that is a global signal. So now let's look at a local signal. Let's see. Let me look for signal and we'll match case. Here's a local signal being used. So this one, you notice it's not referencing signals because that would be my global signals. This one's emitting a local signal, and it's emitting done waiting for shield bash. So for a local signal, it has to be defined up here at the top of the class itself, and we have to make a connection to it at some point. And in the local signal case, because I've defined this up here, I can't reuse that same name here. So in those cases for local signals, I tend to just prefix it with on, which is, I think, fairly common. And so and this one's an interesting case because we are emitting a local signal and it is calling basically an empty function. And the reason we're doing that is because there's another somebody who listens for this local signal. And this is, let's see. Done waiting for shield bash, is that? Yeah, so we're using, in the same class, we're listening for that signal and we're waiting for it. So the code won't proceed until that signal has fired. And so we're able to call into an animation, let that animation be of whatever length it wants to be. I can go in there and change that animation a bunch. And let's say it goes from 0.4 seconds to 1.2 seconds. Well, I don't have to remember to go change some weight somewhere and wait for whatever amount of seconds. I said 1.4 seconds. I just have to wait for it to emit a signal when it's done. And this is just a much better way than trying to use like an await like this. I try to avoid as many of these as I possibly can because these always have the problem of needing to be perfectly in sync with other things that you have going on. You change one thing, you have to come back and remember to change the timer. It's dangerous. It gets you into really tricky to debug situations. So anytime you can, try to use like a signal system. So let's look at shield bash here. The shield bash is doing a tween. So we're animating the shield, and it's got all these different timers and stuff going on as it animates the shield bash. But what we're using is the tween for the animation is the tween callback, and this is going to call this function when the tween is done running. And the callback here is going to then call the global signal, done waiting for shield bash. Did I say global? The local signal, done waiting for shield bash, and that lets us know, that lets our where is it? Our perform shield bash sort of sequence of animations. So this is like a full sequence of animations. It's got like 10 different animations that happen, and we can just wait for each one. And yeah. And so I don't know if I've explained it that well. So I'm sitting there thinking I'm kind of just rambling on, jumping all over the place. But I do use a few awaits here, and these are for effect. You can use them safely at some places where you're not waiting for an animation of any kind. Like your animation is done, nothing is happening in the game, so we can just wait for effect and then continue on. We reset the shield bash here. Again, we're using a bunch of tweens. This one we're not waiting for, right? This one is just bringing the shield back, and we're going to let that one go because we don't care about it. We're going to apply a stunned effect to the target. Again, we're not waiting for that effect. It's just going to apply immediately. And then we wait to show damage on target unit. We do this one because we apply a bunch of effects to a unit that takes damage. We do the text damage float that floats up. We flash the unit. We apply damage to it, and then what else? There's something else. Oh, the health bar we update. So all those things happen, and what we don't want is we don't want to move on too quickly while that unit is animating a bunch of things, especially the flashing red and white, whatever flashing red, because if we move on too quickly and another unit takes a turn, or that unit takes a turn and starts performing animations while its damage animation is happening, then you can get into some wonky states where like animations get canceled, the unit stays red because they were in the middle of flashing red, things like that. So important to wait. And then wait for unit to move back to start position. So this is when it flies back to its starting position. We want to wait for that to happen before other things happen too quickly. So that's global signals, that's local signals. I do have, let's see, how am I going to find it? Wait. I should be able to quickly see it here. Here it is. For our arrows. So this is a different version of awaits. So normally we're awaiting a global signal. And in this case, we're awaiting an object's local signal. So this is kind of cool. So this arrow is going to be created, and once it gets created, it flies across the screen, and we're waiting for it to fly across the screen and hit its target, and that's what this await is for. It's like, do your thing. I don't care if you, and the reason I had to use one of these local awaits is that arrows take a variable amount of time. If an arrow shoots at a frontline unit, it'll be done in like 0.4 seconds. But if an arrow hits a backline unit, it'll take like 0.5 seconds. And so I needed to be able to handle that variability. And so if we look at this signal is defined on the arrow. It's defined up here on the arrow. It's like a local signal, right? And we connect to it right here, again, using on-range weapon. And again, it's empty because the only reason we're using it is to listen for when this signal gets called. And so somewhere in here, yep. So here's our physics process. This is what sends the arrow across the screen. When it reaches the target, we emit a local signal, but globally somewhere somebody is listening for it. So that's kind of cool. I don't know where it went. Arrow, piercing arrow ability, maybe. Yeah. So this guy is listening for that local signal. So it's pretty cool. This was new, a new usage for me in this project, so I was pretty excited by it. All right, so that's all of our signals. Talked about unit inheritance, and then maybe we'll talk about abilities in the battle system. So here's our battle manager. It's pretty big. Here's our core loop. So every time a unit is done doing its thing, we call back into advanced battle state. So we're going to check if the battle's canceling. We're going to check if either team has won and trigger those workflows. We're going to check if the game is paused. We're going to give everybody a bit of ability juice, mana, their ult bar, whatever you want to call it, and then which mode are you using? So this is where I determine, like, if you're using the team mode, the speed mode, or the team speed mode. We'll jump into the team battle step here. So we determine whose turn it is, and then if the player still has, if it's the player's turn and they still have available units that need to act, we're going to take their turn. Otherwise, we're going to change the turn to the enemies, and then we're going to loop back around advanced battle state. And then unit takes turn. So we set the unit to has acted, and we check to see if they have anything that's blocking their ability to take a turn. If so, we complete their turn after a short time for effect. And then if they can take a turn, then we're going to unit performs ability. And this is where it gets interesting for the abilities, is that first thing we do is we go, hey, active unit, what's your best possible ability to perform? So we'll go look at that. And let's see, forget, that one is under the base unit. And so in the base unit, we store all the abilities for each unit here. So we look at those. We look at whether they have enough mana to cast the ability. And then we get targets for a given ability. And let's see here. So this now calls into the ability to say, hey, do you have any targets available for yourself? Because each ability will have different types of target needs, right? Am I attacking an enemy? Am I healing a teammate? Am I attacking 3 targets, 1 target? Will I attack invulnerable targets? So if we look at, I like Fireball. Let's look at Fireball. That one is straightforward. You understand what it is, right? And here's its get targets for ability. So each ability defines its own because it has to filter out its own targets. So for the Fireball, it's going to get the enemy units. We're going to start with those. Then we're going to remove any ones that are dead because maybe there's an ability that revives dead units, but we're not. We're not going to target dead ones. And then we're going to remove any that have invincibility currently, because why target them? That would be pointless. And then we're going to also try to find the most injured unit on the board, meaning the unit with the least amount of health, and we're going to target them. So each ability can really fine-tune its logic for what it targets. And then we always return a list of targets, even though for the Fireball it's always going to be 1. And so and the way so we're iterating through the abilities of a unit, and every unit has 2 to 3 abilities. You have we'll call it your ult tier, right, which is the highest priority. And so abilities are sorted by the highest priority, so ultimates have the highest. And then you have your second tier ability, which usually requires some amount of ability juice, like 50 points. And then you have your bottom tier ability, which is free, and it's, your melee attack, your ranged, your basic ranged attack, single arrow ranged attack, things like that. And so we always look at the ult, and if we can find a valid target, if we have the ability to use and we find a target, then we're using our ult. If not, we go to the next one, and if we can find a valid target and we have the juice for it, we're going to cast our second tier, and if not, we're always going to end up casting our bottom tier ability. Okay, and so Fireball is actually a bottom tier ability, and so if it returns a target, we're definitely shooting a Fireball. And so once we get down here, if we had a target for this ability, that means we're using the ability, so we return it. So let's go back to where this gets called. Okay, so now we've got an ability. It should never be null at this point. This is possible if all units are okay. So yeah, so if all the units are invincible on the other side, it is possible that a particular unit has no abilities that can target invincible units. The only one that really can target invincible units at this point is the Archer's ultimate that shoots 3 random arrows at 3 random targets, regardless of invincibility. So it is possible to get null, and I think that just ends your turn. Otherwise, if you have an ability, we're going to move the unit to the foreground just to bring it to Z index to the front, so you're not sitting behind other units when you're attacking. And then perform ability, which is right down here. We're passing in the unit that's performing it and its ability. And we're going to spend our ability juice. This is only really applicable in the way I have it set up for ults, right? Other tier level, I made them all 0 because I always wanted my ult bar to grow for the demo and testing purposes. It's really weird to have it set up in a hybrid way where some of your abilities are spending your ult ability, right? And so you never get to your ult ability. So I was like, well, that's dumb. So, but I didn't change the design. But now you just have to have a certain amount in your ult bar in order to cast a certain ability, but it doesn't spend it. Okay. So once we spent our ability juice, we're going to now call into just this sort of general purpose function. So what we end up doing is going, hey ability, give me the ability function you want me to call. And let's see. So we end up storing, there is right here, ability callable, get ability function. So let me see here. Right here, yeah. So we're going to use the Fireball ability. So in the Fireball ability, I have this variable called ability callable, and when it gets called, it's going to call perform Fireball. What that allows is for me, our battle manager, to know nothing about what function it has to call. It just has to call whatever gets returned here, which will end up being perform Fireball, which will end up calling this function here. And every ability has a different function name, might have multiple, but that just, it really simplifies what the battle manager has to know about. So it worked pretty nice. One of my first times using like callables in that way. I don't know if there's a name for that, but it's pretty clean. So here's our Fireball, and we've got the active unit because the target is stored in the ability itself. So we determine the damage. Here's our target. We get off the base ability, and then we get into our animations, which we kind of already talked about. We're waiting for the staff animation, and then we fling the Fireball. Then, like the arrow, we're waiting for it to travel across the screen. Then we're waiting to show the damage on the target, and then we finish this ability. And so let's look at, actually, let's just follow this a little bit further. All abilities will call this at the end to say, hey, I'm done. And then in the battle manager, it's listening for the signal. And go to it here. And so we're going to move the unit back to the background in terms of Z index, and then we're going to advance the battle state. I do have to look in here. I may have to terminate this so that we don't end up in an infinite loop, but I think with all the signals and everything else, that's not an issue. But I need to double check it just to make sure that we're not creating massively large call stacks. I don't think I am. Anyway, let's see. So that's it. That's basically everything I really wanted to cover. Let me look through my scene to see if there's anything else in here that would be interesting. Effects, they're also scenes. So here's like a burn effect. So when the fireball hits the target, we spawn a burn effect, and then we put it in the units, which I showed before. We put it in a node container of the unit, and then it just does its thing and then cleans itself up. That's how most of these effects work. So the burn effect is actually a temporary effect. The entanglement effect is a sticky effect, which will stick around for a few rounds, and it gets managed by the battle system. And so we can see here that when it starts, it sets a bunch of basic parameters, and then it animates the entanglement in, which are vines growing out of the ground. And I use a process for this one because I had some trouble trying to get the box rect animating correctly. I just couldn't get it to animate the way I wanted to, up and down. So I ended up using a process to animate it, which is a little bit heavier, but it works. And so all the other effects are one of those two, temporary or a sticky effect. And we can look at each effect here. Pretty simple. Let's see, anything else? I got the managers, projectiles, sound effects. Yeah, I think that's about it. This project is available on itch.io. I should have the link down below. And that's it. So let me know if you have questions, feedback, thumbs up if you can afford it. And then as far as what I plan to do with this particular project going forward is, I don't know. I think maybe I can add some new mechanics, new systems, just keep growing it piece by piece here and there, kind of based on interest, but not sure. So kind of be based on what I hear from you guys. So let me know. Cheers. Bye.